The African savanna has no rules and no intervention. Here, physical strength determines which individuals persist. Each time the largest animals appear, natural order is immediately tested. This opens the most severe confrontations on this land, where blood, sweat, and survival instincts collide directly. The dry season spreads across the savanna. Green grass disappears. Temperature rises and water becomes scarce. Pressure weighs on all organisms and forces constant vigilance. A single moment of contact can trigger a conflict with no retreat. African Cape buffalo are among the most dangerous hoofed animals on the continent. The body is massive and an adult male can weigh approximately 1,980 pounds. Large mass combined with fast reflexes and immediate threat response makes any collision with this species extremely risky. In many ecosystems, buffalo are classified within the Big Five, not because they are rare, but because of the level of injury they can inflict when pressured. When conflict occurs between two adult males, it is not a random encounter. It is a full-force confrontation where all muscle mass of the neck, shoulders, and head is engaged. Both individuals charge at high speed and generate extreme impact force. Pressure focused on the head and neck is sufficient to transmit shock through the entire body. These contests usually serve to establish hierarchy or access to females within the herd. The key factor that determines impact tolerance in male buffalo is the boss structure on the forehead. This is the horn base that thickens with age and later fuses across the forehead into a solid bone mass. This structure does not exist in juveniles. Bone density in this region is extremely high and absorbs and disperses force. During frontal collisions, individuals with a continuous smooth boss are typically males that have survived multiple confrontations. Buffalo horns do not serve only as protection. They are actively used for attack. During a charge, the head lowers and horns point forward, hooking into the body or neck of the opponent and lifting forcefully. This tactic causes even large predators to carefully evaluate risk before approaching a healthy adult. Selective pressure operates continuously. Bone structure, strength, and damage tolerance determine which individuals pass on genetic material. A minor error in a single collision can alter survival outcome. Such confrontations are never isolated events. Along slow-moving rivers and extensive wetlands of Africa, hippopotamuses control space in a very different manner. Most of the time, the massive body remains submerged with only eyes, ears, and nostrils exposed. The surface appears calm and can be misleading. In reality, this is one of the most dangerous mammals on the continent, with exceptionally high aggression when territory is violated. A hippopotamus can open its jaws extremely wide, approaching a straight line. Large jaw structure and a short but extremely strong neck generate tremendous bite force at close range. Most body mass is distributed across shoulders, neck and head, which stabilizes attacks on land and in water. Movement is not fast over long distance, but is explosive and precise in confined space. Territorial behavior in hippopotamuses is maintained continuously and does not follow seasonal patterns. This pressure contributes to limiting population density in wetlands and narrow river sections. Hippopotamus habitat therefore remains a high-risk zone for any organism that enters. During each wet and dry cycle, African savannas enter a period of major transition. Millions of hoofed animals move in the same direction, following fresh grass and water sources. This flow includes approximately 1.5 million blue wildebeest, hundreds of thousands of zebras, and large numbers of gazelles. The scale compresses space, restricts visibility, and amplifies every mistake. Within this movement, wildebeest and zebras often appear together. This occurs not due to shared social behavior, but because of complementary biological traits. Wildebeest possess well-developed hearing and olfaction. They detect unfamiliar scents, abnormal sounds, and ground vibrations from long distance. These signals allow early response to predator approach or environmental change. However, a short neck structure and grass obstruction limit direct visual observation when moving in dense formation. Zebras provide a different layer of surveillance. Tall bodies, heads held above grass level, and eye structure allow wide area scanning. A broad field of view enables detection of movement from multiple directions simultaneously. Combined, the two species form a distributed warning system. Sound, scent, and motion are processed in parallel, reducing the chance of surprise approach. However, herd structure does not operate on mutual protection. Each individual reacts based on direct survival benefit. When a predator has focused on a target, the remainder of the herd tends to separate, increase distance, and reduce personal risk. Returning to assist does not provide evolutionary advantage under constant pressure. This apparent indifference is a product of natural selection rather than behavioral error. Zebras traveling thousands of miles face heavy pressure from food shortage, herd collisions, and constant threat. Common responses include strong kicking and maintaining personal space. Within dense movement, any obstruction that disrupts travel rhythm can be attacked, including juveniles of other species. Despite strength and strong senses, zebras remain primary prey. When light decreases, predator detection weakens. Individuals that separate from the herd, fall out of rhythm, or move alone become easier targets. During the Great Migration, position within the herd and ability to maintain movement rhythm directly determine survival probability. Even when buffalo herds maintain position against predators, the hierarchy of power on the savanna does not end there. At the highest level stands the African elephant. A single individual is sufficient to exert pressure across the surrounding space. Elephant presence alters the behavior of many other species without the need for formation or collective response. The ground vibrates lightly with each step. A safety distance is established immediately. The African elephant is the largest land animal alive today. An adult can weigh up to about 13,000 pounds and stand over 13 feet at the shoulder. This mass creates an absolute advantage in any confrontation. No predator chooses to approach a healthy elephant directly. The risk of injury is immediate and uncontrollable. Elephant body structure is optimized for power. The trunk is the most prominent feature. With more than 40,000 independent muscle bundles, the trunk provides high precision for fine tasks and strong pulling force in conflict. It can strike, push, lift, or hold objects at a safe distance. In many situations, trunk movement alone is enough to force other species to retreat. Elephant feet are another under-recognized tool. Large contact surface combined with body weight generates extreme pressure when placed on the ground. A precisely placed step can destroy vegetation, deform soil, and cause severe injury to any organism within the impact zone. This power does not require speed, only position. A common savanna anecdote involves so-called marula fruit intoxication in elephants. Surface observation shows some individuals moving unsteadily after consuming marula fruit. However, biological analysis indicates that alcohol intoxication is very unlikely. To affect the nervous system of a multi-ton animal, the required quantity of fermented fruit far exceeds natural conditions. Elephant digestion also operates, rapidly limiting alcohol absorption. Another hypothesis involves insects living in marula bark. Larvae of certain species contain compounds with mild neurological effect. When elephants consume bark, the combined intake may cause temporary balance disruption. Additionally, stimulation from nutrient-rich food sources can lead to unpredictable behavior. Regardless of cause, an uncontrolled elephant in confined space always represents high risk. On the savannah, safety limits around elephants are clearly defined and rarely challenged. Rhinoceroses exist as a biological paradox. The body is massive, with weight that can exceed 3,080 pounds. The skin is several inches thick with dense fibrous structure that is difficult to penetrate. A horn on the nose grows continuously and is hard enough to break most obstacles along the movement path. This strength is paired with a serious limitation, which is very poor eyesight. Rhinoceroses do not see objects clearly at long distance. Beyond about 98 feet, images become blurred shapes without defined form. Details cannot be distinguished. Intent cannot be identified. In open environments such as savannas, this turns any unfamiliar signal into a potential threat. Rhinoceros' survival reflexes are built around this limitation. When unfamiliar scent appears or abnormal sound is detected, the nervous system shifts into high alert. There is no prolonged observation phase. There is no multi-step assessment. The response is nearly immediate. The chosen approach direction is straight ahead. Speed increases rapidly over a short distance. The objective is to remove the source of disturbance before it approaches closer. As a result, collisions with non-living objects are not rare. Dry tree stumps, dense bushes, large rocks, and even stationary vehicles can be interpreted as threats if they enter the sensory zone. For rhinoceroses, there is no concept of correct or incorrect response. There are only two states, which are safe or must be removed. Stress reaches its highest level during the breeding season. Adult males expand their activity range and increase contact with other individuals. Pressure on females rises noticeably. A commonly recorded behavior is the expulsion of older calves from the area near the mother. This interrupts the care process and accelerates the return of the reproductive cycle. For females, this period requires continuous defensive response to protect dependent offspring. The most severe conflicts occur when two adult males dispute territory. Both approach in straight lines with heads lowered and horns pointed forward. Rhinoceros horns are made of keratin, which is the same biological material as nails and hair, but densely compressed. At high-speed impact, the horn can penetrate thick skin and cause deep injury. These fights do not end quickly. They can last for hours, with repeated separation followed by renewed charges. Rhinoceroses are designed for pure strength. However, limited perception and high territorial behavior place them in a state of constant conflict. On the savannah, every charge by a rhinoceros carries risk for other organisms and for the species itself. The greatest advantage of African buffalo does not lie in individual animals, but in herd structure. When gathered in sufficient numbers, a buffalo herd forms a tight, coordinated moving mass that is extremely difficult to approach. An adult male often weighs close to 2,000 pounds and possesses a dense skeleton, a powerful neck, and outward curving horns. The dense formation shields all approach directions. Under these conditions, even top predators rarely choose a direct attack. The herd response occurs very quickly. When the boundary is breached, individuals on the outer edge immediately turn toward the threat. Those in the center maintain stable positions. The entire herd shifts state within seconds from stationary to active movement, expanding control of the surrounding space. The pressure does not come from a single animal, but from combined mass movement and synchronization. However, this structure is only effective when it remains intact. An individual separated from the herd faces a much higher level of risk. An adult buffalo may exceed the body mass of a lioness, but this does not guarantee complete safety. Predators do not rely on direct force confrontation. They focus on exhausting, disrupting, and sustaining pressure on the isolated target. Such hunts often involve coordination among multiple lionesses. They rotate approaches, forcing the opponent to move continuously. The objective is not immediate takedown, but reduction of response capacity. These situations occur repeatedly across the savanna, creating continuous interaction cycles between predation, defense, and re-establishment of spatial order. Not every dangerous predator in Africa requires speed, massive size, or conspicuous movement. In many ecosystems, the most effective threat comes from organisms that produce almost no signals. There is no sound. There is no warning. There is no prolonged pursuit. A single moment of close approach is enough for the event to end. The African rock python is a typical representative of this hunting style. It is the largest legless snake on the continent and operates primarily through concealment and patience. The long, heavy and flexible body allows absolute advantage in confined space, where quick reflex matters more than speed. The prey range of the African rock python is very broad. Medium-sized hoofed mammals, primates, wild pigs and reptiles living near water are included. After the prey becomes immobile, the python begins swallowing from the head. An expandable jaw structure allows enclosure of bodies much larger than head diameter. Within African ecosystems, the African rock python does not require direct competition with larger predators. Its strategy relies on surprise muscular endurance and control of prey within extremely short range. For the African rock python, silence is not a resting state. Silence is the optimal condition for ending a hunt. The survival stage in Africa does not belong only to massive bodies. At the edge of this system exists a much smaller species. That is known for an unusually high level of risk-taking behavior. The honey badger. It is a medium-sized carnivorous mammal recorded in the Guinness World Records for confronting opponents that exceed it in size and biological weaponry. The honey badger has a unique body structure. The skin layer is about 0.24 inches thick and is not tightly attached to the muscle beneath. The diet of this species includes many dangerous animals. Snakes make up about 1/4 of the diet. The honey badger has strong venom tolerance, which allows continued movement and counterattack after being bitten. However, this advantage is only effective against opponents that rely on venom. When facing a predator that does not use chemical toxins, the entire strategy must change. The African rock python is one such opponent. There is no venom. There is no need for repeated biting. The attack method relies entirely on constriction. When the body coils tighten, venom resistance has no value. On the savanna, willingness to engage produces many victories. When facing pure mechanical strength at the highest level, persistence no longer determines the result. Among these species, one bird holds a central role and can alter the order of an entire feeding event. The lappet-faced vulture is such an individual. Large body size, assertive behavior, and direct access to food sources that most species cannot reach define this role. This bird has a wingspan near 10 feet, which places it among the largest in Africa. This size allows rapid access to large carcasses and maintenance of a dominant position. When it arrives, other species usually withdraw. This is not due to numbers, but due to body structure and biological tools. The thick, curved, sharp beak can penetrate the extremely thick skin of elephants, buffalo, or rhinoceros. This is material that many other scavengers cannot process. In natural decomposition, nutrients are often locked inside thick skin and dense tissue. Without an initial opener, much biomass would not be accessed in time. The lappet-faced vulture performs this exact role. It creates an entry point. After the protective layer is breached, smaller vulture species can access the soft tissue inside. This activates the entire scavenger system. However, this order is not equal. The lappet-faced vulture holds the central position, selects the most energy-rich portions, and feeds first and in larger amounts. Only afterward do other species feed. This relationship is bidirectional. Smaller species require the penetration ability of the larger species. The larger species benefits from group gathering that improves carcass detection over wide areas. The name lappet-faced comes from the folded bare skin structure around the head and neck. When activity increases or competition occurs, blood flow concentrates in this region. Skin color shifts from pale to deep red. Recent physiological studies show this helps release heat during high-intensity activity under strong sunlight. At the same time, the strong color signal functions as a visual warning and reduces the need for direct conflict. The lappet-faced vulture is not only a scavenger, it is a decisive link that controls the speed and efficiency of energy redistribution. When this species disappears, large carcasses persist, longer decomposition slows, and many other species are affected. Its presence keeps the biological cycle operating at the correct pace. This large animal does not rely on canine teeth and does not depend on forelimb strength. The primary advantage comes from vertical reach. The African giraffe reaches nearly 20 feet in height and occupies a spatial layer that most other animals cannot access. Height is only the visible feature. Behind it is a biological system designed to counter gravity itself. To move blood from the heart to a brain positioned more than 6 feet higher, the giraffe body functions as a high-pressure pump system. The heart weighs about 24 pounds, with thick muscular walls and strong contractions. Blood pressure is about twice that of humans, but is tightly regulated to prevent vessel rupture. One way, valves in the neck veins prevent blood from rushing downward when the head is lowered. The brain remains protected from pressure shock even as posture changes repeatedly. In the giraffe world, height does more than support observation and feeding. It determines reproductive order. The long neck is the result of prolonged evolutionary pressure, where body structure governs both survival and competition. The greatest threat to large animals does not come from teeth, claws, or natural competition. It comes from humans. When large species persist, the entire ecosystem retains structure and functional rhythm. If they disappear, nature becomes depleted, weakened, and unable to self-regulate. Decisions and actions occurring at this moment will determine whether these species continue to live in the wild or remain only as records in scientific archives.